Hello folks, welcome to this video on our Winter 21 question paper 4.2. We're looking at question 6, physics question. As soon as you see a roller coaster, you know it's a physics question, right? Okay, we are going to talk through the model answer, we're going to talk through my mark scheme, and if you've got any questions, comment below the video, I'm more than happy to help. So, we're going to start off by looking at this roller coaster track, okay, and we want to think about where we have the least gravitational potential energy. Now, this is where it's a good idea to remember the link between gravitational potential energy and height. So what we're looking for is the lowest height. Okay, if you are low down, you have less gravitational potential energy. Well, clearly there's one very obvious one, it's D. Okay, D is the lowest height and therefore it will have the lowest gravitational potential energy. Okay, now, a little sort of comment on quite a lot of these things. You'll notice that our answers are DAD, and we'll talk through the other ones in a second. But generally, extremes are quite hard, are quite obvious choices if you don't really know what to answer. Okay, I'm talking to the people who are sort of struggling with this and thinking, you know, that it's not really for them. In physics, we are often interested in what happens at the extremes. So when you have no mass or when you have lots of mass. Okay, and that goes with this question as well. Here we're looking at top and bottom. All right, and you'll notice one of our answers is the bottom, the next answer is the top, and the next answer is the bottom again. All right, so you know, if you're ever struggling, these introductory questions are usually fairly light, not too labor intensive in terms of sort of thinking about things too much. And so I always encourage students to have a go at a question. You can always make an educated guess, okay, as to the answer, try and rule out some different options and go from there. So in this case, it's actually a fairly simple one. Now, let's go for it. All right, we want to look at a point where we have less kinetic energy than it does at position E. Now, this does actually take a bit of thinking, okay, contrary to my previous statement. Okay, let's think about this. When we have energy conservation, the higher up I am, that means the more gravitational potential energy I have. Higher, more gravitational potential. Well, the flip side of that is the more gravitational potential energy I have, the less kinetic energy I have. So really, when we're looking here at the point of our point A is the point at which we have the least kinetic energy because we have the most gravitational potential energy. Okay, and so therefore, when we've got the least kinetic energy, i.e. less than at E is the second least, A is going to be least because it's the highest. Now, let's think about that in the same terms for the next point. Most kinetic energy, well, it works the other way. If I go down, my gravitational potential energy goes down, my kinetic energy heads up, and so therefore I'm actually traveling fastest at the bottom, and that's energy conservation for us. Okay, now here we go with the next part. So okay, we're being asked to do some calculations. Okay, first things first, we're being asked to calculate the gravitational potential energy lost by the roller coaster as it moves from sea to ground level. Okay, now let's just have a look at point C. There we are, we're at point C. Okay, and we're told that point C is 36 meters above the ground level. Okay, so let's have a look. Gravitational potential energy. Potential energy makes us go G higher, H. Potential energy makes us go higher. Okay, and so therefore EP equals to mgh, one of the few equations in GCSE sciences which is not simply two variables multiplied together, it is three. But if you can do 2, you can do 3. We know our M is 750. We know G is 10, and you're told this. Don't use any other values for GCSE. And then we're told the height H, which is 36 meters, 750 times 10, 36. We've got 270,000 joules. Okay. We're then being asked to calculate the kinetic energy. We're told in the question, and every time just go back, revisit the main text, moving V 20 meters per second, M is 750 kilograms, okay, and our EK is a half mv squared. I tried in another video to come up with a mnemonic, I wasn't very happy with it. Energy means we have to go faster, or very fast, something like that, okay. This is one you're going to have to remember, all right. E equals a half mv squared, remembering that square, 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 okay. Now, if we put our numbers in, we get our 150,000. Okay, noticing that they're not necessarily the same value, that might be something to look into later. Okay. All right. Now, We're being asked here to state the change in the total energy of the roller coaster car. Now what we're thinking here is the total change in gravitational and kinetic energy. In other words, if at any point we were to add the two values together, kinetic and gravitational potential, what would we get? Okay, or would it change? Well, energy is taken out of a system due to dissipative forces, and one of those forces is friction. So normally we would have friction taking energy out of the system. However, let's have a look there. The system is frictionless, so there is no dissipated energy, and what that means, no energy is taken out, and so actually the change in the total energy is going to be a big fat zero. Okay, this is one of those questions again which, if you overthink it, you can get yourself a bit stuck, because you might confuse, for example, total with gravitational potential. You might read friction instead of frictionless, whereas actually there's no energy being taken out here, nothing wasted, it's zero. Now you can kind of see that here from our 1 mark in terms of the question, all right? It's a 1 mark question, so you'll probably be having to state a value. If it wasn't 0, it might be one of the previous answers that we've given, but in this case it's 0. Okay, we've then got a speed time graph. Oh, lovely stuff, all right? This is where we should be. Okay, I know that a lot of you guys have done this in maths. Okay, we're being asked to determine the change in speed of the roller coaster between 2 and 4 seconds. So the thing to do here is get that ruler out. I know you don't do it at home. I know you don't do it in your homeworks. But the one time you do it is in your exam, okay? Obviously you should do this all the time. And you draw the lines. You find the speed at 2 seconds and at 4 seconds, okay, which would be 32 and 10, and you find the difference between them. The change in speed is simply the difference between the two, all right? And actually, if I'm being 100% accurate, it should be minus 22, because the speed has gone down by 22, but it doesn't matter. CIE does not care about that minus sign. Only a 1 mark question, but one that I hope you can all get. You're then being asked to calculate the acceleration of the roller coaster, okay? Now, again, I've had a go at trying to come up with a mnemonic, not happy with it. Acceleration changes velocity over time. Well, actually, not bad. I'll give myself a 7 out of 10 for that one. Acceleration changes velocity over time. Okay, we've got a change in v, which was calculated in the previous question, and we've got a change in time. Now notice, key point, we don't use the number 4 here because the time hasn't changed by 4. The time has changed by 2 plus 2 equal 4. So therefore, 2 seconds is going to be our time on the bottom there. We've got 22 divided by 2 equal to 11 meters per second squared. Now, the question would be here is, if you made a mistake, what would you get? Okay, well, if you, for example, calculated the wrong value in the first one and then used that value in the second one but used it correctly, you'd get 2 marks here. What you would lose marks for is using the wrong time. Okay, remember, it's the change in the time, not the value of the time at the point we're measuring. That's a very crucial little difference, quite a subtle one. Okay, we'll finish off by using figure 6.2. Oh, using a figure. Using a graph, okay? If you're going to use a graph, talk about the gradient. Okay, why? Because the gradient represents the acceleration. In the previous question, you calculated the gradient in this graph. You may not know that you did, but you did. Okay, all that stuff that you do in maths, you know, that gradient rubbish, it's all useful here in your physics questions. The gradient of the speed time graph is equal to the acceleration, or the deceleration if you like. Okay, and so in this case you're going to have to use it. Now, all right, it's not unfair, it's not sort of over the top to be a bit sort of bit too detailed here. Okay, the first thing you want to say here is that simply we've got the car slowing down. Okay, we can see that quite clearly. Okay, but then you can also see that there are 2 different bits of behavior. We have a non-constant acceleration. In other words, we go from 0 to this value, this 11 value that we've calculated previously. The acceleration here is non-constant because the gradient is non-constant. After 2 seconds, the gradient becomes constant, and therefore the acceleration is constant. Okay, remember, and I've underlined it there, the gradient is the acceleration. Now, I really like this stuff because it really gets you to see what these things mean. As I've sort of jokingly said before, in maths you learn about gradients, you learn about calculating these things, but we don't always know what they mean. Well, in the case of a physics question, there's a meaning, and that meaning very much here is the acceleration. So if you can grasp that and talk about it in your answers, that's showing your understanding and showing your understanding of the links between the maths and the physics. Okay, I'm going to stop blabbering on about maths and physics here because I could be here for a long time. Usual thing, if you've got any questions, please ask them. If you'd like more videos, subscribe to the channel and they will come up instantly in your feed. If not, carry on with your physics revision, have a great time doing it, and remember that it's nearly there, light at the end of the tunnel. You're doing a great job. All the best.